So if you will see 2012 to 2025, right? We have extensive questions, right? So you just see how many questions are coming from which topic. Can you see? Statistical test and diagnostic methods, 22 questions. Means more questions are there. OLS property and CLRM assumption, 15 questions are there. Regression analysis and interpretation, 12 questions are there. Heteroscedasticity, 11 questions. Multicollinearity, 8 questions. Autocorrelation, 6 questions. Time series econometrics, 5 questions. GLS, 5 questions. Hypothesis testing and model selection, 4 questions. R square and model fit, 3 questions. Dummy variable and categorical like data, basically categorical or qualitative regression, basically. So 2 questions, and miscellaneous 5 questions, means different type of regression. Then probability, only few questions are there because earlier questions I have not added to this analysis. So probability theory, which are related in this section also, there are 6 questions. Probability distribution, 5 questions. Now means what actually you have to do, basically. So first of all, you have to because there are very less time, we cannot actually be very in depth, we cannot go. Are you getting my point? So what we will do, based on the questions we will analyze. Okay, so first is you should know which is your highest priority and which is your high priority and which is your medium priority. Okay, so 65% you assess yourself whether you know it or not. Okay, that is one question. Then second, if you will see which is highest priority. Okay, can you see? DW, R square, decay Fuller, dummy variable, unit root, all these are actually, can you see all these tests? These are actually highest priority, means these tests have come actually frequently. Okay.
Yes, sir.
So this is a very good analysis. Okay. So, and if you see heteroscedasticity, what are the tests which are here? Stationarity, autocorrelation, structural break, causality, multicollinearity, specification, and overall significance. So largely your test means these are the different type of tests you should master, or at least you should know them. Okay, because at this point of time I cannot say that you will master this test. Okay, time will say, but for me at least we have to cover these topics. Are you getting?
Yes, sir.
Then next is topic number 2. You just see how extensive is this. Okay, OLS property and CLRM assumption, regression equation, okay, and correlation coefficient, which we are doing. So now if you will see gradually, so they are asking you a lot of application oriented questions. Initially there are questions which are based on the direct formula, but nowadays it is more rigorous. Okay, so on OLS property and CLRM assumptions, how you should prepare, means what are the questions which are there. I will share this document with you. Okay, because it is an extensive analysis. Then because you just see in OLS what are the things at least you should know. Okay, these are the topics I should know, so that it will be easier. Because now what we are doing is we are you have a syllabus and you have a set of questions, we are going just solving each question, but we should have a strategy so that we can finish it as fast as we can, because we have to proceed to the public economics also. Okay, and regression analysis and interpretation, what are the things you have to study? Can you see? Again there is a sub-categorization. So what you are supposed to do is, you will go through each one of these. Better if you can take a printout of this document and you highlight in the highlighter. Okay, which are the red, which are the green. Green means you know, red means you don't know. Okay, so that you can ask me, okay, these are the topics, sir, you should focus, because I am going to discuss. I'll send you also a note based on this only. First a note which you will read, that is a just quick note. It is not very extensive. Two kind of notes I have prepared. One is quick reference, another one is a detailed note, and third one is the question solution which we are doing. Okay, so there is nothing left in this section so far. Then heteroscedasticity, what are the things you should know? Are you getting? So then multicollinearity, autocorrelation, time series econometrics, GLS and advanced estimation methods, because new questions June 2025 bootstrap method was there, sampling distribution basically. Then what is spurious regression, Granger Newbold rule, it was asked in June 2025 question. Okay, then GLS also recently lot of questions are there on GLS. Okay, then we'll go to hypothesis testing and model selection. Then R square, dummy variable, regression type and miscellaneous. What are the different type of questions are there? Now you just see again in probability distribution what are the different type of questions are there. Please read this. Now frequency analysis is here. Are you getting? Which are the questions and what is the frequency of the questions? Are you getting? So now you have to focus top 5 most tested topic that covers 72% of all questions. What are they? 5 most important topics: statistical test, OLS, regression analysis, heteroscedasticity, GLS and advanced. Okay. Now June 2025 is a very tough paper. Okay, and obviously it asked little very advanced question. So that is you can say it is a little departure from how the previous years they have asked the questions. Obviously, now this is how the analysis is being done. Okay, year wise. Okay.
Sir, in 2025, there was no question from linear regression actually, which was very shocking.
That is right. Nah. So because questions are becoming, you just see how it is becoming changing actually. Okay, now it is more application and in-depth questions they are asking from very. If you have read it thoroughly, then only you will be able to answer. So like it will take little time, but at least at this point of time, based on this strategy, at least 65% of the questions will be correct if you are focusing on this. Okay, 35 we are not sure. Are you getting my point?
Yes, sir.
So just go through it and quick check. At least tier 1 highest priority, it is must. So we will focus on tier 1 highest priority. Then obviously we are doing other also, OLS also. So if you will add 65% and 16%, so largely it is coming around to close to 80%. Are you getting? So and also in between also we are focusing on heteroscedasticity, probability, as Sangeeta told, conditional probability. So these are the basic questions which are come actually, conditional probability. So gradually other questions like all 25%, obviously we will focus on that, but first our focus should be 65%. Then medium priority, you will go gradually like this. Okay. So I think matching questions index also it has prepared very nicely. So these are the questions which are repeated. Are you getting? This it means 16% of the entire exam there are a lot of questions we are getting repeated. Okay, these are the topic. It means they cannot avoid these topics. So at least you have to make sure that you are not missing any questions from this repetition. Okay. So this is what I thought I will discuss with you. Then based on this I have prepared this quick reference guide for you, like heteroscedasticity test in short form. What are those tests? Okay, like Glaser test, Park test, White test, Goldfield quant test, Wagon test. What we are doing actually in this test, we will be discussing this also, but I will share with you. Okay. Then Gauss Markov assumption. So red means what is the color code? Red means you should know. Okay. The reading in terms of reading. So the color code shows different priorities. Okay. So what are the things you should know and where you should focus. So now you can see this is just comprehensive formula sheet. Are you getting?
Yes, sir.
So this is based on the matching pattern. Okay. Basically from where the questions are coming, and so this is I think fine. I'll share with you. Okay. Now we'll focus on our discussion. So is this is something interesting? This is useful.
Yes, sir.
Yes, sir.
Yes, sir.
Yes.
Please send us the PDF. We will take printout.
I think this one is very important. Quick reference
Yes,
guide.
sir. Yes,
because
sir.
because manually if you will do it will take a lot of time, because nowadays you are not having time. And what
Yes, sir.
I will do is I will also, if you will Sangeeta, if you will supply me like micro question, because I think Bhakti ma'am is also a little busy. So
Mm-hmm.
I will try to use my technology skills and other personal materials. Okay, and we
Okay,
will
sir.
also do similar kind of question analysis in other sections also, wherever it is possible, because now we are having less
For
time.
Indian economy, sir, we can do so that the AI can give us the recent data
No, 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 no.
compilation.
That is wrong. AI will never a data thing you cannot.
Reliable data we
No, no,
cannot get.
no, no. That is so. That is why otherwise everyone will write research paper citing data sources AI. Okay, that is
Yes,
very
sir.
wrong. Math
Yes, sir.
you can use, because there are a lot of information which are actually repetitive information. That is where the AI will not commit any mistake. Okay, even though chances of mistakes are there, but we can easily find out. But in data, if you ask AI, AI will give you some data by referring some sources, not reliable sources. Are you getting? But yes, we can try. We can restrict the AI to only focus on some particular database, but it will not able to do. So don't rely on that. Better you Pratijogita Darpan, which you have following, you read that.
Yes, sir.
And
Yes, sir.
moreover, I will suggest that I think we will review also one or two
Yes,
sessions
sir.
Indian economy. So
Yes, sir.
where we will be using some latest government World Bank data, latest government website. We will go and we will read from there only. We will verify, cross verify the data which is there, even if in Pratijogita Darpan also. Like I think that day in the workshop there is some report. One madam was telling, Mitali Chinara madam, World Inequality Report or something. She told it came recently. Okay,
World Inequality Report. Okay, sir.
I have never read, but we have to cross verify where this report is being published and what is the status of India, because the reports which are actually recently, means last 1 year, if there is any updation in any report, so your strategy should be focusing on those reports which are recent. Okay, because usually they will not ask you very old data. Okay.
Sir, actually, in the last June session, they asked the NFHS data, NFHS 5 data.
NFHS 5. So we can focus on NFHS, NSSO latest round. Okay.
Yes, sir. Yes.
NSSO latest round. Then I think Planning Commission. Some of the development programs, I think, which is going on. That there will be some questions also from there, isn't it?
Yes, sir.
I don't know.
Yes, sir.
Sangita is reading. I think she will be able to tell,
Yes, sir. Yes, sir.
because I am not reading Indian economic session. So, what kind of questions are there, Sangita, in Indian economy? Largely,
Sir, question relating to agriculture, poverty, unemployment, recent survey data, sir. Survey data questions.
So what I can do is with we can use AI tools just to um, how we can focus. Okay, based on the previous question, we will not use the data from there,
Yes, 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 sir.
but yes, if we can cross verify, okay, but
Yes,
at
sir.
least we can prioritize, okay, like
Yes, sir.
some kind of better strategy or where we can
Yes,
focus,
sir.
because that
Yes,
is
sir.
the
Indian
need.
economy is scattered, sir, so it is
So it
difficult.
is very difficult to read everything,
Yes, sir.
and sometimes you will feel sleepy also. Like if you
Yes, sir.
will read these data because they are never ending, na.
Yes, sir.
So and also public finance data will be there, like GST, recent revisions in GST. Okay,
Yes, sir.
Yes, sir.
so I think we'll have a question test also. So what I'll do is I'll last part we can have multiple tests. Okay, but I need little help in setting up the Google test actually. So let us see if I can get any student. I think I will use. Because if you are writing means you should not help, right? Then you will know
Yes,
the
sir.
answer. So,
Yes, sir.
this reference I am going to share with you. Okay. So let us see how it is going to help you. Okay. Now let us focus on what we are doing. How many questions we did, Sangeeta? Progress was very little slow, but we
Yes,
are
sir. 11.
11. 11 or Darwin Watson.
Sir, from now on, mostly all the questions are repeated only, sir. Means the conceptual part we have already studied. Next, all the question will be, sir, we can easily discuss quickly.
No, yeah. No, that is fine. What I am telling you,
Question number, sir. Um,
this is it. Now we will go one by one, okay? This
yes,
question we did. This question also we did, right?
yes, sir.
For any pair of variable x and y, two regression equation, one regression of y on x, and tangent thing, na? Where we
Yes,
got
sir.
like little
Confused.
confusion. So this is also we did. Then question number 3 also we did. Darwin Watson. Then dummy variable already we did. Coefficient of determination. This is also we did, right? Then presence of heteroscedasticity, that day it took a lot of time. So we did this, right? This is a summary. Please read this. Okay, where we will use GLS in case of autocorrelation, right? GLS is the most preferred method. Okay, generalized least square. So this summary you should know. In case of you write it and you memorize this. Okay,
Sir,
like
please send us this PDF also.
I was correcting the errors na before I sending to you. So
Okay, sir.
now I have kind of finalized all econometrics material, so I will share with you. Not a problem.
Yes, sir.
Because it took lot of time actually to finalize actually. Otherwise, I have to cross check also na whether it is coming as per my expectation or not. Then this question already we did, right?
Yes, sir. Yes, sir.
I remember. I have remembered all this. Then this one also,
Yes,
ignoring
sir.
heteroscedasticity, it will be inefficient, right?
Yes, sir.
Wireless estimator will be inefficient, right?
Inefficient.
Yes,
Yes, sir.
integral so did
This
matching.
one
This
last we did.
contains the last we did also this one
T-test and
contains
F-test
a
we had
table.
studied in this.
Contains a table. Then this one we can see.
This from this we have to do.
This is a question, very interesting question. Production function. In if you have read Gujarati, it is coming straight away from the Gujarati book only. I think they are following largely Gujarati book. Okay. When they are setting, because based on my understanding, the questions largely coming from Gujarati only. Okay. Because I have read chapter by chapter, na? So I can
Yes,
easily
sir.
identify the type of questions. They are, the people who are setting it is they are setting only from Gujarati. Damodar Gujarati. So what it is saying? Acha, what is Sangeeta? Which kind of model is this? Can you see?
Log regression model, sir.
They are called log linear
Log linear.
or double log. There is a classification, na?
Yes, sir. Log model.
See, let me show you. See, can you see? This one I was trying to tell you. This will help you. Functional form. Okay. Is it visible to you? Hello.
Yes, sir.
Sangeeta is not there.
Yes, sir. Yes, sir. It is visible.
So linear model. Can you see? First of all, this is a linear model where there is no log. So the interpretation of slope is when x changes by 1 unit, whatever the measurement unit of x will be there. So like that. Then what will be the impact of on y? Means your y will change by beta 1 times. So that is why this change is written over here, beta 1. Okay, clear? Log linear model, dependent variable is log, but independent variable is not, it is in original form. So we use log linear model to measure the growth rate. Okay. If I remember, I told you once, maybe you have forgotten. Then lean log model, where the dependent variable is in original form and the independent variable is in logarithmic form. ln stands for what, Sangeeta? ln, what is the difference between ln and log? Madhusida? Hello?
Yes, sir. I don't know, sir. Actually,
No, I told also one day, na? So
log.
in log, actually ln means natural logarithmic. Natural
Natural
logarithm.
log.
And it is actually logarithmic log base 10 basically. It is base 10 and this is base E. E is your 2.71, whatever the value is there, right? So base is different. Here the base is 10 and here the base is E. Okay? Clear?
Sir.
Okay.
Natural log base is E.
E, yes. That
This
is
is
a special number, right? What is E? Do you know what is E?
no, sir.
Madhusida, 1 second. Just I am coming.
Okay,
Sir,
sir.
1 second. Yes, Madhusida. What is E?
sir, basically E refers to the constant.
Hmm?
Constant, sir.
E is a constant. Everyone knows that. What is anything extra you are saying? You are saying something?
Sir, basically in my idea it is constant.
Okay. Yes, you are very good. So basically E is Euler's number. Okay, E is called Euler's
Euler's number.
number. So approximately is like you can say it is 2.71. I told 8 to 8. So and it is basically irrational number. Okay, it means irrational means the decimal will go on forever without a repeating pattern. Okay, like it will go on 7 1 8 2 8 again 1 8 2 8 like this 4 5 9 0 like this. Okay, and it is the base of the natural logarithmic ln. Okay, are you getting?
Yes, sir.
So basically where we use ln, you should know to calculate the continuous compound interest, population growth. Okay,
Yes, sir.
and also like little extra information. Who discovered this number? He is a famous, what you can say, person who is associated with statistics also. Jacob Bernoulli. Bernoulli distribution is there, na?
Yes, sir.
Yes, sir.
He discovered long back, 1683. Imagine. Hmm? So now what we should know? So natural logarithmic you have understood, right? Or is there any problem?
No, sir.
Because natural logarithmic function, your log function we use usually basically when we are measuring the growth rate. Okay, you will be writing like this. Okay, how you write? Who can tell? You write like this. Suppose natural logarithmic we write ln x, right, like this, right, or we write log base e of x. Clear? And similarly common logarithmic, one is natural logarithmic, this log log base 10 x, it is called common logarithmic. Okay, so usually this is called common logarithmic because this function is using a base of 10. Clear?
Yes, sir.
I hope this is clear, right? So why we are doing? Because it is going to be used later on in many places. Okay, now you just see in our model. So next model is lean log model. Your dependent is normal as it is and independent is ln. So how you will interpret? You will interpret like this. Whatever the beta 1 will be there, you will divide by 100. So you will interpret this is as percentage. If you will interpret like this, if there is a 1% change in x, okay, then whatever change will be there in y. Okay, so that will be in original units. Repeating that beta 1 will refers to change per 1% change in x. Okay, clear? Then log model. Log model, one benefit is beta 1 directly represent the elasticity. So in production function, we will come back to our original PDF. So can you see the purpose why I told you the different functional form? Because this is a, you can see here it is ln is here, ln is here, x3 is also ln, x4 is ln. So what is the benefit? These numbers, these coefficients, right? So estimators. So what they are giving? They are directly giving you elasticity. isn't it?
Yes, sir.
Yes, sir.
That is what I was trying to tell you. That is directly it is saying a log model. So other models also you should remember. Okay. So here how it is representing elasticity, because beta 1 is change in ln y due to change in ln x. So that is because we know that log, if we will directly, it gives us the percentage interpretation, isn't it? Percentage change. I hope you know the mathematics, right, of this change in ln x, how change in ln y due to change in ln x. So that mathematics, if you are not sure, we will do some other day, not a problem. Now what is the question? Let us focus on the question. R square is 0.89. So returns to scale. It is saying whether it is constant, decreasing, increasing, neutral. So it is very clear. So what you will do is, you should not add this beta 1 intercept. Okay, this is an intercept. Only you have to add the slope only. See 0.31 minus 0.05, 0.53, 0.37. So that is 1.16 greater than 1. So it means mathematically it is giving you increasing returns, but what is the elasticity coefficient, means what is the formula of Cobb-Douglas utility function? Madhusita?
Sir, the parameter only, like the alpha and beta only shows the elasticity, sir. Like
A to the power.
Cobb-Douglas function is y is equal to
1 minute, I'll show you. I'll show you. 1 second. Where you should read this part.
a k alpha l beta. Sir, y is equal to a into k alpha l beta, where alpha and beta are the elasticities.
Okay, that is fine. So let me show you the book I have actually econometrics. So books, if you will go to Gujarati, one second, think. Teaching sessions. Where we had books, Gujarati, Damodar Gujarati. Okay, because best thing is we can follow. Go to multiple linear regression, because the source is very important. Okay, where you can read this, I'll just tell you. You will go to multiple regression. There will be a section on this. You have the book. This is the problem of estimation. In estimation, it will be there. See?
Yes, sir. Cobb-Douglas production is.
Yeah, in estimation you will find. Okay. So if we go here, let us see. This one. See what it is saying? If your regression model, so let us focus on this, okay? Because this question sometimes it will come. So this is your Cobb-Douglas production function, but usually we don't add E, because when we teach microeconomics, we don't add E. but it is econometrics, so that is why we have added the stochastic form. Okay, so your y is output, x2 is lever, x3 is capital, like that. Okay, u is your stochastic disturbance term. So now first of all, is this a linear model or non-linear model? Means what?
Non-linear model, sir.
So what it is saying, the relationship between the output and the inputs is non-linear. However, if we will log transform this model, we will get, after the log transformation, we will get this, right? This model was given in the question. So this model is linear in parameter, and now it is non-linear in the variable y and x, but linear in the log of these variables earlier. Okay, so it is basically a double log model, or you can say log linear model also. Clear?
Yes, sir.
Now beta 2, what is beta 2? Beta 2 is the partial elasticity of output with respect to the labor input. It measures the percentage change in output for say 1% change in the labor input, holding the capital input constant.
Constant.
Okay, because
Yes, sir.
it is saying beta 2 ln x2i, right? The coefficient is
Yes, sir.
beta 2. So beta 2 is with respect to labor, because if you see the original function, so
Yes, sir.
this was
That is
clearly
the power
written,
of H2.
x2 is clearly, it was written labor, and x3 is
Yes, sir.
capital.
Capital.
Okay, so likewise beta 3 is the partial elasticity of output with respect to the capital input, holding the labor input constant. Okay, when you are interpreting one coefficient or one variable, you have to keep other variables constant.
Yes.
Okay, that is how you will interpret the multiple linear regression. Okay, now the summation of beta 2 and beta 3 directly give you the returns to scale. Okay, it means the response of output a proportionate change in the inputs. So if this sum is 1, then there is a constant returns to scale. Then doubling the inputs will double the output. Okay, so what do you mean by that? Constant returns to scale. Tripling the inputs will triple the output, and so on. And if the sum is less than 1, then there is a decreasing returns to scale. So doubling the inputs will less than double the output. So finally, if the sum is greater than 1, therefore increasing returns to scale. So doubling the input will more than double the output. Clear? So now let's see. Now what is? Let us see the one result. So here let us see. Suppose if this is a regression. Now the question is whether there is a increasing returns to scale, decreasing returns to scale, or constant returns to scale. Sangeeta, how you will derive?
By adding the
Oh,
parameters.
yes, this is right. Beta 2 and beta 3. Right?
Yes, sir.
Clear? So now if you will add these two, how much it is coming? Just see. 1.9887.
1.98.
887. So definitely there is a increasing returns to scale, because beta 2 plus beta 3 is greater than 1.
1.
Are you getting?
Yes, sir.
Now when we go to question, can you just check your question bank? Why the
Yes, sir.
answer is decreasing?
Yes, sir.
Or is there any problem? Quickly check.
Yes, sir. Yes, sir. 1 minute, sir. Question number, sir, is was
9.
9. 1. 9. Answer is showing increasing returns to scale.
Increasing
Returns to scale.
returns to scale, then it is fine.
Yes, sir. 1.116.
So C na, so the answer will be C, right?
Yes,
Increasing.
sir.
I think the order will be different, so that is why there is a typing error, I think here.
9C is only given, sir.
That is what. So that is why it is, we have cross check. So this kind of errors sometimes it will be there. We have to cross check and accordingly you have to see. Okay. So this is clear, right? Now,
Yes, sir.
so parallelly you just open your test bank and we will see if there is any inconsistency. Okay.
Yes, sir.
And once you will get this PDF also, you come back to me. So these are the error which are there. Okay.
Yes, sir.
So next question is, OLS consistency, unbiased efficiency requires what? Expected value of Vt is equal to 0. So Vt is basically error term, right? And variance of Vt is sigma square. Covariance of Vt and Vt minus j is equal to 0. Fourth, Vt is normally distributed with mean 0, variance sigma square. Now, what should be your answer? Is the answer is all D?
Yes, sir.
Okay. So what is this? Means in terms of words, can you tell me? Means what?
Yes, sir.
What is this?
Yes, sir.
What this expected value of Vt is equal to 0 means what?
Sir, actually, it is showing the properties, sir. Like EBT is equal to 0, variance BT is equal to sigma square.
So basically it is saying
Mean value of
0
error term
mean,
is 0.
yes, mean value of error term is
0
0.
mean.
This is
Yes, sir. Yes, sir.
homoscedasticity assumption, and third one is the no
Essential for
autocorrelation.
unbiasedness.
No autocorrelation assumption.
Like, sir, for unbiasedness and consistency and efficiency, what are the properties, sir? Like, we did
No,
not derive it. So these are the properties.
no, yeah, it is like this
Can I
only.
explain, sir? It is written here.
Yeah, can you tell me?
EBT is equal to 0, expected value is equal to 0. The assumption ensures that the expected value of the error term is 0, which is essential for unbiasedness. Then next, variance BT is equal to sigma square. This assumption implies that the variance of the error term is constant, which is crucial for the efficiency of the OLS estimate.
Okay.
Then next, covariance VT minus 1 is equal to 0. This assumption ensures that the error terms are not correlated across observations, which is important for the efficiency of the OLS estimates. And last one, what is this sign, sir? Called? Belongs to N.
Distributed.
Distributed.
Normally distributed. Normally distributed.
VT normally distributed 0 sigma square, while the
With mean 0 and variance sigma square.
okay, sir, with mean 0 and variance sigma square.
Yeah.
This assumption of
Yeah, you are correct. Means actually whatever it is written in short form, so it is what it is saying. These four assumptions needed for OLS to be blue. Okay.
yes,
With
sir.
valid
Yes, sir.
inference. Means
Yes,
if
sir.
you want to draw a valid inference, then your error term should satisfy all these property. Simple. One
Yes,
is
sir.
unbiasedness, efficiency. So all these whatever you told, so those are required for actually checking the or drawing a valid inference regarding your model. Okay, so that is self understood, and this is also given over there. Okay, shall we proceed to the next question?
Yes, sir.
So this answer key just use cross check. Okay, so somewhere if there will be mismatch, you just see. So these are the formula which we did, means we are going to use, means 11 to 79. Okay, so question number 11, diagnostic, regression diagnostic. Okay, so which of the following are the source of autocorrelation in a linear regression model? First of all, what I told you regarding autocorrelation, although we have not studied in detail in theoretically, but what I told you previously, where you find the autocorrelation problem in a time series data, right? So
Yes, sir.
now let us see omission of relevant explanatory variable from the model. Obviously, in this case, it will not be there. Interpolation or extrapolation in statistical observation. Incorrect specification of the true random term B. Many economic variables move together over time, showing persistence. D is correct. Means this is IV. Okay. This is I. This is double I. This is triple I. So IV will be this C or D. The answer will be C or D. Which is the answer, Sangeeta?
Sir, 11 is B. B, sir.
B.
B, 1, 2, 3. How?
Okay.
Okay.
No problem.
B.
Which of the following are the source of autocorrelation in a linear regression model? Answer is, which answer is there? B.
B, sir.
I, second I, third I. Okay. Let us see. So ideally the answer should be, because usually this is also a very important. Okay, many economic variables move together over time. So I don't know how
Yes,
they told actually, but ideally the answer should be all of the above. Okay, why? Because you just see, autocorrelation means serial correlation. Okay, it occurs when the error terms are correlated across observation, like this. This is the notation. Okay, so in time series, usually the correlation should not be equal to 0. Now the question is, first one is omission of relevant explanatory variables. Suppose let's say that this is a true model. Now you have omitted this Z, then your error becomes Bt, which is equal to beta to Zt plus Ut. Because when you omit a important variable from the original model, so now this is a part of this error term. Are you getting my point? Means your original model is this. Now what you did is you have omitted this variable, important variable. You have only estimated this. Correct, Sangeeta?
Yes, sir.
Then this variable which you have excluded, so then this will be part of your new model. Okay, of the error term of the new model. So that is why now if Z is autocorrelated, so Z is often persistent in time series, then Vt inherits autocorrelation from Zt. So if Ut is uncorrelated, Vt will be autocorrelated also. Example is given over there. Suppose for example, true model is, let's say that C consumption is a function of Yt, income, and Wt. Okay, so what you did, you have omitted wealth. Are you getting? So you have taken only consumption is a function of income only. Now because wealth is persistent, means if somebody's income is persistently affected by the wealth, so this omitted variable will create autocorrelation. So statement 1 will be true. So that will be major source of autocorrelation. Is it clear? In case of first statement is clear. Statement number
Yes,
1.
sir.
How omission of relevant variables will cause autocorrelation. Then second, interpolation or extrapolation in statistical observations. What is interpolation? Interpolation is basically when you fill the missing data points using surrounding value. Okay, you know interpolation, right, Sangeeta?
No, sir.
It means, let's say that you are having data, like for example, Suppose 2022 you are having GDP data, okay, 2023 you are having, and 2024 you don't have data. So what you will do is you will add these two data and divide it by 2 to get 2024 data. Clear? Is it clear?
Yes, sir.
Okay. So basically it will create a artificial smoothness in the data. But how it will create autocorrelation? First of all, interpolated values are coming from the neighbors only, isn't it? So errors at time t will be affected by the errors at t minus 1 and t plus 1. Okay. So it will create spurious correlation in residuals. Suppose for example, here it is giving one data. So quarterly data, suppose you are converting a quarterly data like you are to monthly data. Okay. So obviously when you are converting it, first quarter, let's say that you are having 300. So what you will do is you will put January 100, February 100, March 100. So then definitely these are correlated, isn't it? Because in addition they are coming from 300 only. Are you getting? So mechanically they are correlated values. And extrapolation is extending the data beyond observed range using the past pattern, creating a dependence. Okay. So statement 2 is true. Okay. Then misspecification of the error term also it will be true. Okay. So what is important over here? You should know model specification issues. Like for example, if you have omitted variables, wrong functional form, then missing dynamics, lag is missing, incorrect lag structure. So all of these cases you will have actually autocorrelation. Then in case of data issues, interpolation and extrapolation, measurement error, data aggregation, seasonal adjustment problem. So in all these cases autocorrelation problem will be there. And I think Madhusudha, you had written this, right? In your note I have seen inertia or persistence, isn't it, Madhusudha?
Yes, sir. Yes, yes, sir.
So economic phenomena, wherever these economic phenomena will be there, cobweb effects will be there, habit formation, expectation in case of inflation, then policy lag. So there will be also autocorrelation. Then for statistical issue, data smoothing and moving average, overlapping observation. So in all these cases, 4 possible regions are there. So please try to read and remember this. Okay, where the autocorrelation will come. Are you getting my point, Sangeeta?
Yes, sir.
So now the question is, remember all these sources. What is the shortcut? OIMP. OIMP.
MP.
OIMP. Autocorrelation means OIMP. O means omitted variables. I means interpolation or extrapolation. M is misspecification. P is persistence in economic data. Okay? Clear?
Yes, sir.
So question asks source of autocorrelation. So obviously these are 4 possible plausible sources. So answer is usually all of the above, because if it is all of them are making sense. Okay. So there are a lot of questions are based on this, right? So I think this autocorrelation question is clear. Now let us go to the next question. Question number 12. What is question number 12? You just see. This is much easier. Already we know, isn't it?
Yes, sir.
So Granger test is causality. Okay. Durbin-Watson.
Autocorrelation.
Very good. Then unit truth test, stationarity.
Stationarity.
Then which is Box-Jenkins.
Last forecasting.
Box-Jenkins means forecasting. Okay, ARIMA method. So which one will be the correct answer?
A to
IV.
sir. C.
C. Okay. Very good. Now let us see. So C is the correct answer. So it is correct answer. So part 1, Box-Jenkins means forecasting. What is Box-Jenkins methodology? You should know. Box-Jenkins is a systematic approach for identifying, estimating, diagnostic ARIMA model. What is ARIMA model? Autoregressive integrated moving average. Okay?
Yes, sir.
ARIMA. Autoregressive integrated moving average. We write like this. We write ARIMA model like this. ARIMA, comma P, D, Q. We say AR autoregressive order P. Integrated or differenced D times. Okay. Then moving average order Q. Order means basically the number of times or how many lag terms we will keep in the first case. Just you know this, okay? How we write. Clear? Now,
Yes, sir.
Box-Jenkins method. So, if you are interested, you can read, okay? What is the Box-Jenkins procedure? So, now I think we don't need right now because maybe it will be like little more in depth, but I have kept it here. Whenever we need, we can read it, okay? So, now we'll come to here. This is important. Box-Jenkins is forecasting. It is used for ARIMA model building. You should know this. Dickey-Fuller stress is stationarity. Durbin-Watson already you know. Granger causality, why we use? For causality testing purpose. Basically it is used predicting relationship. So what are the related tests you should know? Phillips parent, KPSS that day you had explored. Then
Yes, sir.
Lejeune box test. So this is also another test for autocorrelation. So this is something you have to know. This is a new concept. Then Durbin H, autocorrelation of the lag dependent variable. This is also another test. Then co-integration, like similarly Granger. So Johansson's method or test is used to check co-integration. Okay, you know what is co-integration?
No, sir.
Okay, co-integration means, suppose I think Madhusuna you are teaching macro, right?
Yes, sir.
So when you are teaching consumption theory, okay, so we say what? The two variables, okay, will converge or in the long run equilibrium. They will be in long run equilibrium, isn't it?
Yes.
So which are the theories where you have studied this? Consumption theories, isn't it?
Yes, sir.
Long run equilibrium. There will be long run equilibrium between what?
Consumption.
Permanent income hypothesis you have studied, isn't it?
Permanent and real. Sir, yes.
Life cycle hypothesis.
Long run equilibrium where you will.
Relative income hypothesis.
So now co-integration is a method which gives us idea is there any long run equilibrium between two macroeconomic variable or any other variable. Are you getting my point?
Yes, sir.
So through this econometric method we can identify two variables. So that is, of course, it should be backed by the theory, okay, whether there is any long run equilibrium relationship between them or not. Clear?
Yes.
But there is some certain conditions are there, but right now you should only know to estimate long run equilibrium relationship, okay, long run equilibrium relationship. We use joint co-integration method, but Granger, actually there are two people who are actually very famous with co-integration test. One is Engel-Granger method. What is it? Engel-Granger. Granger got Nobel Prize, okay, in economics. Engel-Granger method also it is popular. So It is not here, I am just telling you. And then Johansson Jusselius. Okay, Johansson Jusselius method. So these two methods are used for quantification. So why I am telling you? Because let's say that if they will change, rather than Granger, if they will write quantification, okay, you should be able to link. Okay, is it clear?
Yes, sir.
Now these are the different formula. Okay, so that you don't need. So now we'll proceed to the. So already we know all this autocorrelation. If it will be 2 means there will be no autocorrelation, isn't it?
Yes, sir.
So Granger equals to causality. So Granger is sounds like danger. So be careful. It is not true causality. You getting?
Yes,
Means
sir.
so it tests basically predictive relationship. Okay. Now we'll go to the next question. If OLS method is used, presence of autocorrelation which is misleading. You have to tell me the answer. Quick.
OLS used in presence of autocorrelation.
Coefficient estimate will be biased or hypothesis test will give you wrong conclusion. Forecast will be biased. Standard error will be inappropriate. All of these are true. So what is the answer? Can you check in your case? The answer which you are having?
1 minute, sir. 13. Question number 13 is D, sir.
D.
Yes, sir.
What is D? D means
D is all of the above.
all of the above. Okay. So there are actually discrepancy. We will discuss that. Some are genuine, some are like little we need to review.
Options are also different, sir. Here it is written coefficient estimate may be unbiased.
Maybe. Because it has sometimes questions based on that only. Right?
Yes, sir.
Maybe. Some cases it is there, like where there is a little errors. So now let us
Sir.
discuss. Then is there any difference? Means first one is coefficient estimate may be biased, right?
May be misleading, sir. The
Maybe
statement is coefficient estimate may be misleading, not
misleading.
biased.
Misleading means bias. Huh? So second is hypothesis test will give you wrong conclusion. Is it there?
Hypothesis test could reach the wrong conclusion.
Third, forecast bias.
Forecast made from the model could be biased.
Short form it is given.
Yes,
Standard
sir.
errors
Standard error may be inappropriate.
maybe. ठीक है, that is fine.
Hmm.
So then the answer will be all of the above, right? So it means what is the answer? Under autocorrelation you should know OLS estimators. Okay, coefficient may be biased, okay, may be misleading. So is this true or not? So it is saying coefficient remain unbiased, but in your answer it is saying so it is actually all of the above. So now what we will do, we will just quickly go to the autocorrelation chapter. You can verify, okay? Because that is why I told you always refer the books whenever it is required, okay?
Yes,
Now
sir.
if you will go to autocorrelation, just check what is the page number, because you are having the same book.
No, sir. I have different one.
Okay, there you can go to the autocorrelation chapter, not a problem. It will be last, towards last. Actostochasticity after that. See, autocorrelation is here. Negative autocorrelation is coming, na? Yes or no? This is autocorrelation. Okay? Detecting autocorrelation. Here it is there, right? How you will detect the autocorrelation? isn't it? Chapter number 12, huh? Now, what are the tests are there? Dublin Watson test already you know. Is there any other extra information are there? Bruce Godfrey test is used for autocorrelation. Please remember this, huh?
Yes,
Bruce
sir.
Godfrey test. This is something. Then Ron's test. Ron's test. Okay. This is also used for autocorrelation. Please remember this. Then okay, remedial. GLS is the remedial method. Okay, just remember GLS, and we use new waste method. Okay, new waste method also. This is also extra information. Okay, for you. Clear? Now, so another correcting the part. Now it will be see what it is saying. First, since the OLS estimators are consistent despite autocorrelation. Are you getting my point?
Hmm.
Clearly written, na?
Yes, sir.
What it is written? So, it is written over here. Maybe somewhere it will be written. Forecasting. I'm just checking the final sentence. Additional large model summary. Summary, let us see summary. Although in the presence of autocorrelation, OLS estimators remain unbiased, consistent, asymptotically normally distributed, but they are no longer efficient. Is it clear?
Yes, sir.
But what is your book is saying? What was your first statement? Coefficients may be misleading. Right?
Yes, sir.
May be misleading. So this is like misleading and bias. Are they synonymous? Yeah, because
Yes, sir.
when they will
Can
be
be.
bias, so in that sense,
Yes.
the answer is answer key. Can you see? There are errors, isn't it? Because you are saying I, second I, third I, fourth, everything is correct, na? All of the above you are saying, isn't it?
Yes, sir. Then option 1 will be true only, na? Because we read that if OLS method is used in presence of autocorrelation, then coefficient are unbiased only. Here it is written biased, which is misleading.
What
Sir, just now in the conclusion part, we have read that
means
if
what?
coefficient
OLS,
that
if you are using OLS when there
in
is
the
a
presence of
presence of
autocorrelation,
autocorrelation, OLS
yes,
estimators are unbiased
remain
only.
yes,
Remains
unbiased
unbiased.
only.
But here what is written?
It
Coefficient
is biased.
biased written, na? So it is not correct, na?
Yes, sir.
That is what I am
Which
saying.
is misleading. Yes.
It
So
is
option
not
1 will
correct.
be yes.
D is all of the above, na?
Yes, sir. The
But this
question
is
is
not.
asking
Which is?
question is if OLS is used in the presence of autocorrelation, which of the following will likely be the consequences?
Okay. You are saying this is the question is wrong, right? If the OLS
Yes,
method
sir.
is used in the presence of autocorrelation, which of the consequence is Tell me.
Which of the following will likely
Hmm.
be the consequences?
Will be the consequences. But this is not the consequences, na? How coefficient estimates are not biased? They are unbiased, right? So it means
Yes, sir.
this. So this
Coefficient
is not
estimates are
correct, na?
unbiased.
This is not correct.
Yes.
That is what I am trying to tell you. I don't know.
Mm-hmm.
So then only second, third, and fourth will be actually true. Are you getting my point? You just see it is written, na? Means TF chi-square test cannot be legitimately applied.
Sir, here in the explanation it is written that
No, no,
when
no.
autocorrelation
Huh.
when
What?
autocorrelation is present,
Huh?
OLS estimate of the coefficient may still be unbiased, but they can be misleading because they may not represent the true relationship between the variables effectively.
Then there is no point, na? May be misleading. You have to say only one word, right?
I think, sir,
Mislead.
here unbiasedness and misleading are two different things, sir. But I can guess from the sir explanation.
No, I don't agree. Okay. So if they will go by misleading, where the coefficients are there, very clearly it is saying, na, like if your autocorrelation is there, okay. So then what happens to the coefficients? Coefficients are unbiased. Means what? Why they will be? If they are unbiased means what? You apply your thinking process, Sangeeta. It
Yes,
means
sir.
expected value of beta 2 hat is equal to beta 2. Are you getting my
Yes.
point? Then why they will be misleading?
Yes, sir.
Are you getting my point? Yes or not?
Yes, sir. Yes, sir.
If they are blue means unbiased, but
Best
efficiency is not
leading
there.
adjustment.
Efficiency is not there. Okay,
Yes, sir.
but other things are there. So
Unbiasedness and consistency.
if unbiased is there, so misleading concept will not come. Okay. Now it
Okay,
is
sir.
subject to
Okay.
your interpretation. So because we are, they have in the book, it is not, they have not referred where they are,
Yes, sir.
which source they are saying. Okay.
Yes, sir. Question is not clearly see, sir.
Biased and misleading. You have to read Gujarati to confirm it. Okay.
Yes, sir.
But based on this assumption, this option is seems to be correct. All of the above, you have to interpret the
Yes, sir.
first statement. Okay.
Yes, sir.
Forecaster bias, standard autocorrelation affect efficiency and inference only, not unbiasedness. So OLS still consistent, but here there is no problem. Standard errors can go wrong. So you see, that is the reason why T and F test will be unreliable. Okay. And
Yes,
forecast
sir.
biased because autocorrelation pattern is not valid. Here the answer is correct, but only the first sentence misleading word is little. You have to check.
Yes, sir. Yes.
But we have analyzed all the statement, that is important. Okay.
Yes, sir. Yes,
Then
sir.
which is false? Just see if there any error here. Is this correct? This question.
Sir,
Question number
14.
14. What is question number 14? Which of the statement is false in the following? T distribution was given by Gosset. Triple stable. Binomial distribution is symmetrical. It is clearly the regression. Already we know this. These two are correct, right? Binomial distribution is symmetrical
Yes,
if
sir.
B is equal to Q. Regression
Yes, sir.
coefficient y on x is equal to r into sigma x upon sigma y. Yesterday we are discussing, right? So
Yes, sir.
if you will see, so this one is not very right over here. Rather we will see. Just remember this, okay? Question
Yes, sir.
number 14. So which of the is false? Can you tell me?
Yes, sir. Option D.
That's what I am telling you. All other options are correct. So what it will be? This one?
Sir, R into sigma y by sigma x.
Yesterday only we did, right?
Yes,
So
sir.
all other statements are correct.
Correct.
So then 15. Which of the following is true in the context of statistical test of hypothesis for two variable linear regression model? I told you so many times, isn't it? Do you
Yes, sir.
remember?
Yes, sir.
What is that? C. Answer. T square will be F. 15C.
15 is sir given A.
I don't think why it is given. See, T square is F. Is there in the book. So that is why I don't go by because in a bivariate regression model I can prove it. T square is F. Why they have given I don't know.
Sir,
But
here they have given some explanation.
no, no,
They have also given that.
I usually don't read from the manual which they have not given any reference. Are you getting my point?
Yes,
So we
sir.
will. So that is the problem. You have to read the book whenever if you are getting doubt.
Yes, sir. Yes, sir. 100%.
So if you think because
We don't
this,
know the concept only, sir. Then we cannot rely on the guidebook.
that is what T square is F. There is a proof is given over here. T
Yes, sir.
relationship between T and F. I think yesterday I was discussing. So what it is saying? So it is
Understood.
actually so answer key is A, na?
Yes, sir. Suggesting some special context or interpretation, it is given, sir. Actually,
But this is the standard
this is the formula. The standard
formula.
formula. Yes, sir. It is also given that this is the standard formula where
Uh,
t square is equal to f. But some special case, it is given that t square is greater than f, sir.
but question is here
Under the
direct.
null hypothesis, it is yes. Under null hypothesis, it can result in t square is greater than f. It is given.
But here it is direct, okay? So
Yes,
sometimes
sir.
answer key will be misleading. Status
Yes,
which
sir.
one of the following is true for two variable linear regression model? This is important. There is no special case over here. Are you getting my
Yes,
point?
sir. Yes,
Only
sir.
T square will be F. How the proof will be? I can share with you. Not a problem. Okay?
Yes, sir.
So simple will not go by the because
Yes, sir.
I will go by the book only. So don't refer to the
Yes,
guide,
sir.
okay? So whenever
Sir,
there
in
is
book, which
error,
chapter is this, sir? T square, f square, f.
bivariate regression model chapter number 2, 3, it will be there.
Okay, sir.
I can show you, not a problem. It is there.
Okay, sir. Okay, sir.
Today only I was showing to someone, I think. Madhusinda, I
Actually,
was.
sir, you told in this context when our t value means sample size is greater than t square is equal to f.
Huh?
In the last class, we had studied no T square test, F square test. When we were studying in that class, we had studied that T square is equal
Yes,
to F.
yes, sir.
I'll show you. Then you should remember. This is app test, okay? Single regression model. If you go, you can see. You can see. This is already we have discussed, right? So, one second. Comparing to r square, this is modified r square. This is adjusted R square also. Okay, this formula is also very important. Okay, adjusted R square. I will tell you when it is required, but you remember this. For this formula already I have written so many places. This is very important formula for multiple regression because we have not covered everything. That is the whole problem. If you would have covered naturally, then you should not have relied on the book. Okay, means the guidebook.
Yes, sir.
That is the whole problem. No?
Yes, sir.
Because whenever there will be there, you should know where it is coming. Then only you can cross verify also on your
Yes,
own.
sir. Yes, sir. And
That,
also it is like memorizing everything is difficult, sir, like this way.
you cannot memorize. Na? See, this is the I was telling about. There are these models. It is there in this chapter. So you have to see how the slope is. What is the equation, and what is the slope, and what is the elasticity. If there are
Yes, sir.
1, 2, 3, 4, 5, 6 different type of model. This is there in the choice of
ठीक है फोटो
functional.
उठा के
Huh?
ठीक है सर.
This one, right?
Yes, sir. Okay.
This is two variable extension of two variable regression model. But I am telling you 1 second. Reciprocal. You see the log model. How you can calculate the elasticity? Everything is given over here. Okay. Means functional form of regression model. This chapter is very important. Means you can browse through this chapter, okay? Even though you know it, means some of these things somewhere you are getting the answer, but please try to read it. Means quickly you can go through it.
Yes, sir.
So F 1 second T here it will be there. F regression. See, here it is given or not? What it is given? T square is a theorem. Can you see? The square of t variable with k degrees of freedom has an f distribution with k1 is equal to 1 degrees of freedom. Yes or not? Is it clear, Sangeeta?
Yes, sir.
I cannot. Sometimes I will get little irritated. Okay, that
Yes, sir.
what they are. That is why na this. Who has written? What is the credential of those people? I don't know actually, na. But this is a standard book, na.
Yes, sir.
Even if UGC answers key also, a lot of time there is court cases
Error.
also, error
Yes,
also.
sir.
So don't rely on that. Only you verify the book only whenever there is a doubt. So t
Yes,
square
sir.
is f. Okay. Then question number 16. Question number 16. Best linear unbiased estimator implies maximum variance of the estimator, minimum variance, right? Minimum
Yes,
variance
sir.
of the estimator, unbiased variance of the estimator. Which one is true? What should be the answer? Best means what?
Variance.
Huh? Best means minimum variance, right? Minimum variance, na? B.
Yes.
Right? What is the answer? Is there any difference of answer, Sangeeta?
No, sir. This is B only.
Okay, very good. So once I will send you this PDF, you just tell me wherever there is a discrepancy, okay? So that we can rectify. So minimum variance, best is minimum variance among all linear unbiased estimator. Linear means linear function of the observation. Unbiased means already we know. So Gauss-Markov theorem under classical assumption OLS is blue. Then next question number 17. We will go to question number 17. 17 match, again matching coming, right? So it had been H test. Just now I told you, isn't it? Where we got? A is
Auto
IV,
Autocorrelation.
autocorrelation. So you just see, I used to do like this. A is IV means, okay, I'll quickly say C. But is C the answer, Sangeeta?
Sir,
Is C the
17.
answer?
Yes, sir. Yes, sir. 17 seats.
See, we don't have to even go to the other options also.
Yes, sir. Yes, sir.
But although Goldfield test also I told you just now, heteroscedasticity.
Yes,
Then
sir.
C also, C is your
F
uh,
test, sir.
F test. Here there is a error also. So C F test is done for overall significance of a regression. That also we had discussed, isn't it?
Yes,
Then
sir.
Dickey Fuller test already you know, Test test. Madhusmita,
Yes, sir.
Yes,
is it clear?
Yes, sir.
18. Question number 18 is, let us discuss 18, 19, 20 so that this will be completed. So y is given, question is clear? Y on x on y. So correlation you have to calculate. This is already you know, isn't it?
Yes.
Sangeeta, is there any problem? See,
no, sir.
answer is correct, right? In
Yes,
matching.
sir. Yes, sir.
Okay, very good. Then next question. See, this one is important. R is given, sigma y is there, sigma x is there, x bar is there, y bar is there. Regression of y on x. So you have to remember the equation. Y on x means R sigma y upon sigma x. Okay? This is sigma y, this is sigma x. Clear?
Yes, sir.
So answer will be B.
Yes, sir.
How you got B? Because assuming that if R is equal to 0.6, because it is saying 0.6 na? 0.6 50 divided by 10. Okay, so that is 3. So you got B is 3, means the slope is 3. A will be, once you know the slope, y bar minus B times x bar. Is it clear? You will get 110. That is your intercept. So this is much easier, isn't it?
Yes.
What you should know? Only, you should know this only. R sigma y. But if you will confuse, some people they get confused, they will put sigma x upon sigma y. Then your answer is incorrect. Okay? If you will do this blunder, then you are going to get wrong answer. Are you getting my point?
Yes, sir.
For Madhusmita, I think this one is very easy question, right?
No, sir.
Okay. And for Sangeeta also, it is easy question. So 20, question number 20. Just tell me. For a regression model is like this. Already we have written so many times. The degree of freedom of a test statistics T, absolute value of T, with n observation is what? Means it is saying for test statistics T, n minus k minus 1 or n plus k minus plus 1 or n minus k plus 1. And what is the logic? What is the answer? Already Sangeeta is having the books, you can tell immediately. But what is the, why is the answer? What is the answer, Sangeeta?
Sir, C, sir.
C, n minus k minus 1. Now you tell me why it is. What is n, what is k and what is 1? Madhusmita, quick.
Sir, n minus 1, I know that is the degree of freedom, but nk, I don't.
Actually here also the answer is not matching. So first of all actually it will be n minus k minus 1 actually. Okay. So where you will check, cross check, you cross check this also, like here only. Okay. in inference it is given, okay, for t distribution, okay. So you can see t test evaluating, again here it is given. We showed intimate connection between f and t statistics. Are you getting, Sangeeta? It came again.
Yes, sir.
Okay. No problem. So I'll show you. Actually, t distribution is n minus 2 degrees of freedom. I don't know where n minus k. Question was little tricky over there. I don't know. N minus k plus 1, what it is saying. Because degrees of freedom, okay, we will not go into that. Usually, because it is saying, I think question you have to read carefully, because it is saying for a regression model, the degrees of freedom of test statistics with n observations. So k is basically number of independent variable, number of parameter basically, means slope. Actually there are two ways to look at it. Why it will be minus 1? Minus 1 is for the intercept, okay. Then this n minus k minus 1 will be correct. So what is the explanation it is saying? Same thing what I am telling.
Yes, sir.
Okay. Madhusudha, you got it?
Yes, sir.
K means the total number of independent variable. Parameter means beta naught is also there.
Yes, sir.
Number of variables minus another one is for the intercept. Okay. So that is same as actually sometimes what will happen, the answer can be n minus k also. Are you getting my point? So there is a contention. So if I will say number of parameter like the way Madhusudha told. So parameter beta naught is also coming. Are you getting?
Yes, sir.
So that is why you just see the answer is n minus k also it is written. Including, here it is what it is written, including intercept. If k is total parameter, so that is why you should know, Sangeeta. So clearly it is
Yes,
written.
sir.
So this answer will be your answer will be clear. So that is why I am telling you have to go depth actually.
Yes, sir. Actually, this is confusing it.
That is why explanation is important. K is number of parameter estimated. So if a model is this, K is 3 parameter. Clearly it is written over here. Then degrees of freedom will be n minus 3. Clear? Why it is 3? Beta 1 is 1 parameter, beta 2 is 1 parameter, beta naught also 1 parameter. So the answer will be n minus k. So sometimes you have to see the answer key was also like debated. So now we have covered 20 questions, okay, so far. So these are the topic we have already covered. So I think we have learned many things. So please remember all this, huh? So we'll continue our discussion, right?